Hi everyone, good evening. Good evening everyone. There is a small problem. Today a person is not attending in call. There is a small problem. So hello. Hi everyone. पहले 3 चीजें कंफर्म करना. ऑडियो क्लियर है, वीडियो क्लियर है और मैं हैंडसम हूं. ये 3 चीजें आप कंफर्म करना. पहले आप ये 3 चीजें कंफर्म करना कि ऑडियो क्लियर है, वीडियो क्लियर है और मैं हैंडसम हूं. ठीक है, ये 3 चीजें क्लियर करना. ठीक है, आज का टॉपिक है 𝐂𝐸𝐿 थ्योरम. हमने पंपिंग लेमा को कल खत्म कर दिया है ना. तो एस्टरडे हमने पंपिंग लेमा को कन्वर्ट और पार्टी चलेगी टिल 1:30 इन दी मॉर्निंग. बाद में ना कहना कुछ भी, पहले दे दो वार्निंग. पार्टी चलेगी टिल 1:30 मॉर्निंग. ठीक है, 1:30 तक क्लास चलेगी. कंप्लेन मत करना. ठीक है, दरवाजे को गुंडी मारो, कोई ना अंदर आने पाए. आरबीआर को समझा दो म्यूजिक, गलती से भी रुक ना पाए. टकर टकर जो फील करे वो जाके 2 कप कॉफी पी ले. जिसको डांस नहीं करना है जाके अपना बैच चलाए. ठीक है, ठीक है. ठीक है भाई। तो आज का टॉपिक होगा आज का टॉपिक होगा पंपिंग लेमा। एक्चुअली क्लास 11:30 को शुरू हुआ, मतलब शेड्यूल हुआ था, और भी 3 मिनट बचा है। आप तब तक रिवाइज कर लेना, 3 मिनट तक आप रिवाइज कर लेना। ठीक है, 3 मिनट तक आप रिवाइज कर लेना। ठीक है। और 1 मिनट है। ठीक है, 1 more minute। ठीक है, ठीक है, लोग ज्वाइन नहीं हुआ है ज्यादा। हम 2-3 मिनट वेट करेंगे, 2-3 मिनट के बाद शुरू करेंगे। ठीक है, लोग अभी ज्यादा ज्वाइन नहीं हुआ, 2-3 मिनट वेट करके हम 2-3 मिनट में स्टार्ट करेंगे। ठीक है। Okay, guys, shall we start? Shall we start? I'll start with a story. Dr. Tessie Thomas, India's missile woman. She is called India's missile woman. She was born in 1963, shattered the gender barriers in DRDO's guided missile program under APJ अब्दुल कलाम. अब्दुल कलाम के अंदर काम किया है और तब ना during that time ladies were not given higher priority or higher precedence, but then she broke all the barriers and she became the India's missile woman. After her BE in electronics and communication, she headed the Agni missile projects, overseeing the development and tests of Agni 4 and Agni 5 with indigenous guidance modules. Confronted by tight deadlines, embargoes, and budget constraints, she fostered cross-laboratory collaborations and rigorous simulation trials. Matlab, there used to be a lot of labs and there was no connection between them. Now she made all the labs to collaborate with each other and she achieved a great feat. Okay. And honored as DRDO Scientist of the Year, her leadership expanded India's strategic deterrence and inspired countless women to pursue STEM careers. Sorry. Mike was there. Mike wasn't there. I will explain it once again. Dr. Tessie Thomas hai. She was called as India's missile woman. She worked under the guidance of APJ Abdul Kalam. During those days, women were not given any importance. Women were not given any priority. But she broken all the barriers and she became a woman who has led many missions. She did her BE in electronics. She did her BE in electronics and communication, and then she headed Agni missile projects, overseeing the development and tests of Agni 4 and Agni 5. She worked on Agni 4 and Agni 5, lekin with limited budget she did that. Tight deadlines, right, and limited budget constraints, but still she was able to collaborate with multiple laboratories and rigorous simulation trials. She was honored as DRDO Scientist of the Year. Her leadership expanded India's strategic deterrence and inspired countless women to pursue STEM. I don't know why. I don't know why this happens, but then the problem is, this is a real problem. If you go to any IIT or IASC, in a batch of 40 students, there will be only 2 to 3 girls. Even now, girls are not given the privilege to do higher studies by their parents. This is a burning problem. Even if you go to any IIT, you don't find any girls. Very less number of girls. Even if you go to IASC, 2-3 girls you will find. Right? Even now the situation is like that, but imagine the situation in 1960s. She did all this. She is a hero for me, and I am proud that I am an Indian. I am proud that I am an Indian. Everyone say Jai Hind, Jai Hind, Jai Hind. Okay, guys. Let's now see Myhill-Nerode theorem. Let's now see Myhill-Nerode theorem. Myhill-Nerode theorem. Okay. This is based on minimal DFA. This is based on minimal DFA. Right. I will take an example and explain you what Myhill-Nerode theorem is doing. Okay. I will take an example. Let us say this is a finite automata. Let us say this is a finite automata. So, what will A accept? A will accept epsilon, है ना? What will A accept? A will accept epsilon because A is the starting state, है ना? What will B accept? B will accept set of all strings starting with A followed by A plus B star, है ना? What will C accept? C will accept set of all strings following starting with B. C will accept set of all strings starting with B. C will accept set of all strings starting with B. है ना? है ना? So, if you take any minimal DFA, every state will accept certain number of strings and they are called equivalence classes. So, in this example, there are 3 equivalence classes. ठीक है? दरवाजे को घंटी मारो कोई ना बाहर जाने पाए, RBR को समझा दो म्यूजिक गलती से भी रुक ना पाए, टकर टकर जो फील करे वो जाके 2 कप कॉफी पी ले, जिसको डांस नहीं करना है जाके अपने बैस चलाए. ठीक है? डांस विथ मी, डांस विथ मी, डांस विथ मी. ओके, डांस टू माय ट्यून्स. राइट. So A accepts epsilon, B accepts A followed by A plus B star, C accepts A followed by A plus B star. I am not writing the final states, they are not important. So, any DFA will classify the language into equivalence classes. In this example, there are 3 equivalence classes. One equivalence class contains epsilon, other equivalence class contains A followed by A plus B star, other equivalence class contains B followed by A plus B star. You take any minimal DFA, it will happen. You take any minimal DFA, it will happen. Okay? You take any minimal DFA, this will happen. Okay? So, why don't you try by taking some minimal DFAs? Why don't you try by taking some minimal DFAs? Why don't you try by taking some minimal DFAs? I will take one more minimal DFA and I will explain you. Okay? One minimal DFA is like this. A on A is going to be A is coming back to A, and here it is B, and here it is B, and here it is B. Right? B, A, B. Right? Right. So, how many equivalence classes are possible? The number of states in minimal DFA will give you the number of equivalence classes. If you see A, what is A accepting? A is accepting 0, 1, 2, 3, 4, 5, 6, 7. So if you observe A is accepting all odd number of A's, isn't it? A is accepting all even number of A's. 1, 2, 3, 4. A is accepting even number of A's. Now what about B? B is accepting odd number of A's. Odd number of A's. This is a minimal DFA, right? This is a minimal DFA. This is a minimal DFA. Why don't you take one more DFA and do it? You take a DFA and write it in the Telegram channel about the, take any DFA, write it in Telegram channel about what is the number of equivalence classes and what they are doing. You take it. You take anything and you write it. Not a problem. Okay. I'm seeing your Telegram channel. You take some DFA and you me. Arca has given an answer. Very good. Arca, very good. Arca has given 3 states, 3 equivalent states. My Telegram channel is my Telegram channel is RBR Sir PW. RBR Sir PW. Okay. Let's take one more. I will take one more example and I'll explain you. Let us say the minimal DFA is like this. A on A is going to B, on A is going to C, and again on A it is coming back, and B, A, here I have B, here I have B, and here I have B. Here I have B, B and B. A and A, B, B and B, right? So what does A represent? A represent set of all strings such that number of A's in W is congruent to 0 mod 3. Number of A's in W is congruent to 0 mod 3. What about B? Number of A's in W is congruent to 1 mod 3. What about C? Number of A's in W is congruent to 2 mod 3, right? Right? So it has divided everything into beautifully 3 parts, right? Now if you take all these examples, if I take the union of them, I will get sigma star. What does that mean? A DFA will divide sigma star into equivalence classes in such a way that there will be no intersection between equivalence classes, and if I take all the union of equivalence classes, I get sigma star. I get sigma star. Right, 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 right. Now, if I take union of this is even number of phase, this is odd number of phase. If I take union of this, I get sigma star. If I take union of this, I get sigma star. Right. Now, if I take union of all these three, I get sigma star. This is called Mayhill-Nerode theorem. What is Mayhill-Nerode theorem? A minimal DFA will divide the language into multiple equivalence classes, and for every equivalence class, we are going to have different. For every equivalence class, we are going to have no intersection, and union is going to give us sigma star. You can see all these examples, right? Even Arca has given an example. Arca's example was this. Okay, let's leave out that example. These examples are sufficient. Okay, now let us write about Mayhill-Nerode theorem. Okay, okay. Let us write about Mayhill-Nerode theorem. Mayhill-Nerode theorem is based on minimal DFA. Mayhill-Nerode theorem is based on minimal DFA, and the number of equivalence classes is equal to number of states in minimal DFA. 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 Right? 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 If the equivalence classes are finite, then we can build finite automata. If the equivalence classes are finite, then we can build finite automata. ठीक है? If a language is regular, regular, then it will have a DFA. With finite states. with finite states. So with finite states, if a language is regular, then it will have a DFA with finite states. It will have a DFA with finite states. It will have a DFA with final states. So 𝐂𝐻𝐿 𝐂𝐻𝐿 equivalence classes are finite. 𝐂𝐻𝐿 equivalence classes are finite. 𝐂𝐻𝐿 equivalence classes are finite. Okay. Very simple to understand. Right. Two strings x comma y are equivalent. Two strings x comma y are equivalent. When are two strings equivalent? If both of them start from initial state and reach the same state. Two strings are equivalent if they start from initial state and reach the same state. For example, if I take this DFA, A followed by A comma B star, B followed by A comma B star, right? Now two strings are equivalent if they both go to the same state. If I take this string ABA and if I take this string AAB, both are equivalent. Why? Because from starting state, both of them will go to this state only. Two strings x and x comma y are equivalent if both of them go to the same state. Right. So I'll ask you some questions, you answer me. Okay. How many, I'll give you 5 minutes. How many 𝐂𝐻𝐿 equivalence equivalence classes are in A star B star? How many 𝐂𝐻𝐿 equivalence classes are in A star B star? How many 𝐂𝐻𝐿 equivalence classes are in A star B star? In A star B star, how many 𝐂𝐻𝐿 equivalence classes are there? Arka, you can't answer, Arka. You have attended my class last year. How can you answer it? Arka, don't answer it, okay? After everyone answers it, you answer. Because you have already attended my last year's class. You know the answer already. You know the question and answer, right? Let everyone answer. I will give you 3 minutes of time. Let everyone answer, okay? I'll give you 3 minutes of time. Let everyone answer. So how many Myhill-Nerode equivalence classes are there in A star B star? How many Myhill-Nerode theorem are there in A star B star or in A star B star? Answer this. I'll give you 3 minutes of time. So we have already done for A star B star, right? How are you going to do DFA for A star B star? Now in order to answer this question, you have to draw minimal DFA for A star B star. For A star B star, you have to do minimal DFA, right? So A star B star, after a B, A should not come. After a B, A should not come. Now, how many minimal states are there in this finite automata? The number of minimal states in this are 3. 3 minimal states are there. Therefore, according to Myhill-Nerode theorem, according to Myhill-Nerode theorem, according to Myhill-Nerode theorem, the number of, according to Myhill-Nerode theorem, according to Myhill-Nerode theorem, the number of equivalent states are 3. Equivalent states are 3. Answer me this question. Answer me this question. A power n, B power n such that n is greater than or equal to 0. A power n, B power n such that n is greater than or equal to 0. How many Myhill-Nerode classes are there? How many Myhill-Nerode classes are there? How many Myhill-Nerode classes are there? A power n, B power n such that n is greater than or equal to 0. How many Myhill-Nerode classes are there? How many Myhill-Nerode classes are there? A power n, B power n such that n is greater than or equal to 0. How many Myhill-Nerode theorems are there? How many Myhill-Nerode theorems are there? So A power n, B power n is not a regular language, है ना? A power n, B power n is not a regular language. This is not a regular language. A power n, B power n is not a regular language. Right? Right? A power n, B power n is not a regular language. Therefore, how many equivalence classes do we get? How many equivalence classes do we get? Since this is not a regular language, finite automata is not possible. We need infinite states. We need infinite states, right? Therefore, how many equivalence classes will be there? The number of Myhill-Nerode equivalence classes will be infinity. The number of Myhill-Nerode equivalence classes will be infinity. Infinity. Okay? 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 You do one thing, A power n, B power n, C power n. You do one thing, A power n, B power n, C power n. A power n, B power n, C power n. A power n, B power n, C power n. So how many Myhill-Nerode equivalence classes are there? Infinite. Infinite, right? Now if I give you A power n, B power n, C power n such that n is greater than or equal to 0, again the language is not regular. Again the language is not regular. Therefore, finite automata is not possible. Therefore, Myhill-Nerode equivalence classes, Myhill-Nerode equivalence classes will be infinite. Myhill-Nerode equivalence classes will be infinite. Myhill-Nerode equivalence classes will be infinite. Okay? Okay? Let's see one more story. Have you heard about 𝐂𝐚𝐿? Have you heard about 𝐂𝐚𝐿? The ice stupa innovator. So 𝐂𝐚𝐿, born in 1966 from Ladakh, invented the ice stupa to tackle seasonal water shortages. By spraying winter stream water into sub-zero air at night, he transformed 15 to 20 feet canonical ice molds that melt slowly in the spring, preciously when farmers need the irrigation. These stupas, built without electricity using local labor, recharge aquifers and extend the farming season. As a founder of 𝐂𝐚𝐿, he also pioneered solar-heated, eco-friendly school buildings. His frugal engineering empowers remote communications, right? So this guy is a hero. What he did was, during the winter season, when we get some water, he used to make the water into ice. He used to convert the water into ice. and then when there is shortage of water, he will melt the ice and provide them to the farmers. And he has done many other things. This guy is a hero. You must have heard about him. This guy is a hero. Okay, you might have heard about him. Okay, so now let's write the properties of Mayhew-Nerode theorem. Let's write the properties of Mayhew-Nerode theorem. Okay, so tell me how many Mayhew-Nerode theorems are there in this. A is always followed. A is always followed by a B. Tell me how many Mayhew-Nerode theorems are there. Equivalence. Tell me how many Mayhew-Nerode equivalence classes are there. Tell me how many Mayhew-Nerode equivalence classes are there. Equivalence classes are there. ठीक है, तो every A is followed by a B. What is the answer? How many Mayhew-Nerode theorems are there? How many Mayhew-Nerode equivalence classes are there in the language where every A is followed by a B? Every A is followed by a B. How many? I will give you 3 minutes. Answer it. I will give you 3 minutes. Answer it. ठीक है? Every A is followed by a B. A is always followed by a B. How many Mayhew-Nerode theorems are there? How many Mayhew-Nerode theorems are there? How many Mayhew-Nerode theorems are there? So, every A has to be followed by a B, right? Let any number of B's come, I will accept them. Now, if I get a, every A has to be followed by a B, and if I get a after a, it should be killed. It should be killed, right? Every A is followed by a B. If a is followed by a, we are going to kill it. We are going to kill it. Therefore, how many Mayhew-Nerode theorems are there? Did I miss out anything? A comma B, it is done. A comma B, it is done. A comma B, it is done, right? So the number of Mayhew-Nerode theorems are 3. I'll give you one more question. Answer me that question. I'll give you one more question. Answer me that question. Okay. How many Mayhew-Nerode equivalence classes are present, how many 𝐂𝐸 equivalence classes are present in a language, where starting two symbols are same. 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 So, what do I mean by starting two symbols are same? They have to start with either AA or BB, right? So, they have to start with either AA or they have to start with either BB. They have to start with either AA or they have to start with either BB. They have to start with either AA or they have to start with either BB. Right? Right? A accepted or B accepted. They have to start with either A or B, right? Now this NFA is telling you something. What is it telling? Hi NFA, how are you? Okay, how is your girlfriend DFA? Okay, situation is not good. Don't worry, I will help you out. Okay. Oh, you don't have multiple edges. So it is saying that it doesn't have multiple edges. Okay, so I can convert you directly into a DFA, right? When there are no multiple edges, you can directly convert it into DFA without using any algorithm. How? Just write a dead state. Just write a dead state. Just write a dead state. Just write a dead state, right? And then you put all the missing transitions. And then you put all the missing transitions. Here B is missing. Here A is missing. Here B is missing. Here A is missing. Here B is missing and here A is missing. Here B is missing and here A is missing. Right, right. Here B is missing and here A is missing. Okay. What is Asdeep doing? He is saying you are really god of computer science. Amazing class, sir. Is it? If he says anything bad, we can do that. I don't have right to ban anyone. Okay. So how many minimal DFAs are present? Okay. How many states are present in minimal DFA? In the minimal DFA, how many states are present? In the minimal DFA, how many states are present? 1, 2, 3, 4, 5. Therefore, how many 𝐂𝐸-Neurot theorems are possible? The number of 𝐂𝐸-Neurot theorems possible are The number of Myhill-Nerode theorems possible are 5. 1, 2, 3, 4, 5. The number of Myhill-Nerode theorems possible are 5. 5, right? So we have crossed 1 hour. I will take a break for 3 minutes. I will return back in 3 minutes. I will return back in 3 minutes. Okay? I will return back in 3 minutes. Okay? Okay, I'll give you some points about this. Let us say if E1, E2, so on En, E1, E2, so on En are 𝐁𝐻𝐿 equivalence classes. 𝐁𝐻𝐿 equivalence classes. If E1, E2, so on, En are 𝐁𝐻𝐿 equivalence classes, then point number 1 is every equivalence class will contain at least one string. Without a string, there will be no state existing, right? Therefore, every equivalence class will contain at least one string, right? And no two strings will go to, one string will not go to two different states, right? One string will not go to two different states, which means between two equivalence classes, for I not equal to j, between two equivalence classes, the intersection ei intersection ej is equal to phi. Ei intersection ej is equal to phi, right? And the third one is, if I take the union of all equivalence classes, that will be equal to sigma star. If I take all union of equivalence classes, that will be equal to sigma star. That's it. This is called 𝐁𝐻𝐿 equivalence theorem. Okay. Now I will give you tables. You will get 1 mark from this, right? Now I will give you 4 tables. RBR table 1, RBR table 2, RBR table 3, RBR table 4. If you by heart all these tables, you will get at least one question. At least, I am taking at least one question you will get. 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 Very good. Someone has commented TOC means theory of clarity. 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 Now I'll give you a very big diagram. You may not be understanding it completely, but take this diagram, okay? I will be giving you very big diagram. You may not be able to understand it directly. Please take this, okay? Regular languages, deterministic context-free languages, context-free languages, context-sensitive languages, recursive languages, recursive languages, recursive languages, recursively enumerable languages, recursively enumerable languages, and set of all languages. Set of all languages, right? So if a language is regular, it is DCFL, CFL, CSL, recursive, recursive will be everything. If a language is CFL, it is CSL, recursive, recursive will be everything, right? So if you give me a language regular, I can upgrade it and I can call the language as DCFL. If you give me a DCFL language, I can upgrade it and I can call the language as CFL. And if I give a CFL, I can upgrade the language and I can call it as CSL. If I give a CSL, I will upgrade the language and call it as recursive. If I give recursive language, I can upgrade it and I can call it as recursively enumerable, right? So upgrading is possible. Now whatever I am going to teach, now whatever I am going to teach, now whatever I am going to teach, okay, whatever I am going to teach, all these basics are required. All these basics are required, okay. I'm going to give you a very big table. I'm going to give you a very big table, and in that table I will explain you all the properties, okay. So first let us see RBR table 1. RBR table 1. My throat is little bit paining. Let me get some hot water. I will just be back, okay? Let me get some hot water. I will just be back. My throat is little bit paining, okay? My throat is little bit paining. Before going to get water, I want to tell you a story. I will tell you a story and then I will get some water, okay? And the story is M.S. Swaminathan, father of India's Green Revolution. Dr. M.S. Swaminathan was born in 1925, applied genetics and plant breeding expertise from Cambridge to India's farms. So he has done his PhD from Cambridge and came back to India, and he has applied genetics and plant breeding, leading to the Green Revolution. He adopted high yield semi-dwarf wheat and rice varieties like 𝐂𝐤𝐴 and IR8 to the local conditions, optimized fertilizer and irrigation, which means because of him, we are not using lot of fertilizers and we are not wasting lot of water. And he trained thousands of scientists and farmers to do the agriculture. By the late 1970s, India transformed from food shortages to surplus. This is a hero. He is a hero who has transformed India from shortage of food to surplus of food. His integrated approach of research, extension services, and the policy advocacy laid the foundation for sustainable agriculture worldwide. For sustainable agriculture worldwide, he is a hero, right? You should follow such people. We should follow such people. Okay, we should follow such people. He is a hero. Okay. Okay, guys. So now we will see RBR table 1, table 2, table 3, table 4. Before that, I want to get some hot water. My throat is paining. Just be there. Don't go anywhere. I'm going to come back. I will get some hot water and I'll come back. Okay. Today actually my throat is not well, so I'm thinking to stop the class today. Tomorrow I will take extra class. Tomorrow we will go till 2 a.m. Okay? Tomorrow we will go till 2 a.m. My throat is giving me some problem. I am not able to teach. From tomorrow we will take extra classes and I will complete the syllabus. Okay? Okay? All of you, all of you say Jai Hind, Jai Hind, Jai Hind. All of you say Jai Hind. Let's end the class today. Tomorrow I will be able to take extra classes. From tomorrow onwards, I will be able to take extra classes. Okay? All of you say Jai Hind. Okay, guys. Thank you. Thank you, guys.